Hello everyone, my name is Gender and today I'm excited to share my project's titled ALSA Driver for Bela under BeagleBot Foundations and mentored by Julio Moro from Bela. So BeagleBot is a volunteer-driven foundation promoting open source software and hardware platforms that is capable of running high-level languages and operating systems such as Linux and Zephyr in embedded environments. Their missions aligns with the maker communities, especially those building responsive, real-time embedded systems like robots, drones, 3D printers, and in-car compute system, and much more. So Bela is an open-source embedded computing platform for creating responsive real-time interact systems with audio and sensors. With its rich open-source toolchains and powerful IDE, it supports both low-level programming and audio-centric languages like Pure Data and SuperCollide. It's ideal for audio hardware prototypings, creative codings, and responsive installations. So I'm currently pursuing electronics engineering with a specializations in computer engineering in University Technology Malaysia. Throughout these projects, I aim to deepen my understandings of embedded Linux, kernel driver development, and also audio subsystems. So Bela RefCs come with two audio codecs. The first is ES9080Q, 8-channel DAC. Currently don't have Linux support. And the second one is a Texas Instruments stereo codec driver with full Linux support. So for this project, it's primarily focused on developing a Linux ASOC codec driver for the ES9080Q to integrate it with the Texas Instruments stereo codecs into a unified 10 output, 2 input ALSA audio device. Okay, so for benefits for these projects, by adding or upstreaming the driver into the mainline Linux kernels, Bela can use the Linux drivers and APIs, which is allow it to appear as a standard ALSA audio interface, make it easy to use with common audio Linux tools, which simplifies the maintenance and easy porting to new platforms like the upcoming Pocket Beagle 2, while ensuring long-term project sustainability and increase Bela visibility within the open source audio community. This project is structured into 4 main milestones. The first milestone is to implement a codec driver for the ES9080Q codecs that interacts with existing MCSP and DMA drivers. The second milestone is to implement the machine drivers to link to connect both codecs driver to show up as a single ALSA devices. The third milestone will be patch and upstreams the DAC high performance codec, the 8-channel DAC high performance codec drivers. Then the final milestone will be port the ALSA drivers to the Xenomine 4 stacks for real-time performance and reduced latencies. So the ALSA system on chip, or also known as ASOC, is a layer to provide better ALSA support for embedded systems, embedded processors, and portable audio codecs. So it abstracts the audio pipeline into key driver classes: the codec drivers, platform drivers, and machine drivers. So codec drivers is responsible for controlling the audio codecs through I2C or SPIs. They handle tasks like format configurations, power management, mix controls, and DAPM routings. So for platform drivers, these drivers manage the digital audio interface, also known as DAIS, for the SoCs such as MCSP on the TI platforms. And for machine driver is both specific drivers that bind the codecs and platforms DAIs together. So in these projects, we implement 2 codec drivers under the ASOC frameworks. So for the 8-channel high performance DACs, Since there was no existing Linux support, we have to write a new codec driver from scratch. Then for the Texas Instruments stereo audio codecs is already supported upstream with mature ASOC integrations. So then we will implement the machine driver, which is to bind both codecs driver to MCSP and configures the ASOC digital audio interface links so that the Linux ALSA subsystems expose a single sound card with 2 inputs and 10 output channels. So big thanks to BeagleBoard Foundation for sponsoring these projects outside of Google Summer of Code, and to my mentor Julio Moro for his mentorships and guidance for these projects. Thank you for your time. If you would like to know more about BeagleBoard and Bela, you could visit their website at beagleboard.org or bela.io. And if you have any questions, you could drop me an email